Let's talk about moment generating function. Moment generating function is very useful tool to calculate pretty much the moments of of a distribution function. The definition is this. This is mxt is a definite is a notation for moment generating function. It is the expectation value of exponential of tx, where x is a random variable, which is the probability distribution. You, you will calculate the moment generating function by integrating the etx with fx, where fx is the probability density function, as we can do for the exponential function. We can tailor expand it to infinite series. We end up having this as a e to the tx, and if we do the derivative of this moment generating function to the kth power, you can imagine taking the kth power to the tk, tn I for n less than k will go to 0, because if you do the derivative of the polynomial more than what a has, it will go to 0, and if it's equal to k, it will become factorial, and if it is greater than k, if it's greater than k, and it's greater than k, then we have this expression. So we ended up divided this into 3 different scenarios. We have this, which is n equals to k, and this is n greater than k. By plugging this into here with a t to the nth power. So if we do the derivative of to the kth power, will essentially yield x to the k, because if you try to calculate at t equal to 0, this will go to 0. This will become 0. Thus, this term will become 0. So we're left with this term. That's the power of a moment generating function. You can do the derivative at t equal to 0, and you get the expectation value of x to the kth power.